What's going on, guys? In this video we are going to see how to solve a linear first order differential equation. Now here we have the given equation and this is the standard form. Standard form is dy over dx plus p of x y is equal to q of x. Now the first thing we have to do is we have to check whether the given one is in standard form. And if you look at this one, we have dy over dx alone in the standard form, but here we have multiplied by x. So the first thing what we can do is we should always try to bring this one in standard form. Now to get this one in standard form, we have to divide everything by x. So when we divide this one by x, this is going to become dy over dx, and this is going to be 2 over x y equal to x power minus 4. Now let's check it again. Now dy over dx, then we have to have a function with x, that is 2 over x. We have a function with x, and then multiply by y, and the other side of the equation we have another function that has x, and also here also we have a function that has x. So this is now in standard form. Now the next thing what we have to do is we have to find out px value, because we need this one to find out the integrating factor. Now p of x is whatever the value we are adding with dy over dx and multiplying by y. And if you notice, 2 over x is the one we are adding with this one and multiplying by y. So this is going to be our p of x. So p of x is equal to 2 over x. Now we can go ahead and plug it in this integrated factor equation and find out our integrating factor. Now if you plug this value, this is going to be e power integral. Instead of p of x, we plug 2 over x dx. Now we can move the 2 to the front, so this is going to be e power 2 1 over x dx. And if you integrate 1 over x, that's going to be ln x. So this is going to be 2 ln x plus constant. But here we don't have to worry about constant. We just want a variable. And here we have 2 ln x, and also if you want to cancel e and ln, what you have to do is you have to swap this 2 to this side and write it different way, like e ln, and if you bring this 2 to this side, this is going to be absolute value x square, and from this one we can cancel this e and ln, so we are going to end up with x square. Don't worry about this absolute value because we only need this one. It's not because we have an even number, it's always whatever the value you get, we always get this variable, and we don't worry about this absolute value. Now we can go ahead and multiply. So when we get the integrating factor, we multiply this one both sides. So we multiply this side by x square and also other side by x square. And if you multiply this side by x square, that's going to become dy over dx, and also we are going to have x square, and next one is going to be 2x, right? 1x cancels and we are going to have 2xy. After that, if you multiply this side by x square, that's going to give us x minus 2. Now the next thing is we have to separate this one, like this one, and after we separate, just forget about this, because if you do the derivative of this one, you will get the whole thing back. That's how it works. Like when you have this differential equation in standard form, you can always do this because it will work. So after we get rid of this one, what we have to do is we have to integrate both sides in terms of x, right? And if you integrate this one, integral and differential cancels, so this is going to become y x squared. And in the other side of the equation, we are going to add one more to the power, so that's going to become x power minus 1 divided by that power, that's going to be minus 1 plus constant, right? We don't add the constant right here because we can combine it together and add it in the other side. That's how we got the constant. Now y x squared, and we got this one. Now all we need is we have to write this one in terms of y. But before we do that one, let's write this one in better way. Like y x squared is equal to minus 1. X power minus 1 is going to be 1 over x. So we can write this one as minus 1 over x is the same thing, plus constant. Now we have to bring this x square to the other side, so this is going to be minus 1 over x cubed plus c over x square, and this is going to be the general solution of this differential equation. I hope you guys find this video helpful. See you next time.